In this video, I will be discussing linear inequalities and absolute value inequalities. So I just want to give you a few examples of how to work these different types. So solve the inequality, graph your solution set on a number line, and then write your answer using interval notation. So we can solve an inequality like number 1 just like we would solve an equation. So our goal is to get the x by itself. So we're going to start by adding 7 to both sides. So that would give us 4x is less than or equal to 16. Divide by 4. And we get x is less than or equal to 4. Now that we have the x isolated, that is considered solved. And so now what we want to do is we need to realize what that means. So in an equation, the answer would just be x equals 4. So the answer is 4. But this is an inequality. There's infinitely many answers. All the numbers less than 4 are solutions. So if we want to graphically represent our solution set, we can put our boundary point, which is the 4 on the line. This 4 separates the numbers that are answers from the numbers that are not. So for 4, everything that's less than 4 is an answer. So that means this way on the number line, all of those numbers are answers. And we have two ways to represent our boundary point. So since there is an or equal to sign underneath, that means 4 itself is an answer. So to represent that on the number line, we use a square bracket. Alternatively, some people have seen and some books use a closed circle. So either of those things mean the same thing. So whether you use a closed circle or a square bracket, those both are inclusive, meaning it includes the boundary point. Then to write your answer in interval notation gives the range of values that are included in your solution set. It always goes from least to greatest. So the smallest number that will be included, you can see that this goes forever to the left. So it goes toward negative infinity. Negative infinity always gets a parentheses. The parentheses means the endpoint is not included. And then it goes to 4. 4 is the greatest value it can be. And since 4 is included, it gets a square bracket. Okay, so if the inequality would not have had an equal to sign under it, so just to be clear, this is our answer for this problem. This is it, we're done, okay? Interval notation is here, graph is here, solving is here. But let me just do something else. Had we had gotten an answer, or let's just do something completely different. Let's say I had x is less than 1. Okay, so here we would have had our graph and we would have put 1 as our boundary point. It's still less than, so it would go this way. But in this case, it would be a parentheses. The parentheses is what we use when there's not an equal to sign under the inequality. So that means the 1 is not included in our solution set. So 1 itself is not an answer. Everything up until 1 is, but 1 itself is not. And so in this case, your interval notation would be still parentheses negative infinity, but it would end at 1 and it would get a parentheses instead of a square bracket. So again, that's all because the number 1 example had the equal to sign underneath, and the blue does not. All right, number 2. This one, it looks more complicated because of the fractions. But remember, you can simply multiply by the least common denominator and get rid of all of those. So if we're looking at the denominators, 2, 4, and 5, we can figure out the least common denominator of those. That would be 20. And simply multiply both sides by 20. When we multiply both sides, we're going to distribute the 20 to everything. So we're going to end up multiplying everything by 20, and we can reduce. So that'll be 10, that will be 5, and that will be 4. right? Because 20 divided by 2 in this first example is 10. In the second fraction, 20 divided by 4 is 5. And in the third fraction, 20 divided by 5 is 4. So that would leave us, in this first fraction, we have 10 times negative 1 times x. So that would be negative 10x is less than or equal to 5 times negative 5, so that would be negative 25, plus 2 times x times 4 is 8x. Okay, now we want to get all of our x's on one side, so I would subtract 8x from both sides, and that would give me negative 18x is less than or equal to negative 25. And then I want to get the x by itself, so I'm going to divide by negative 18. Now here is a key. If you multiply or divide by a negative, you must flip the inequality symbol. So dividing or multiplying by negative changes the relationship between the two sides. So this is now going to be x is greater than or equal to 25 over 18. So this less than or equal to flips and becomes a greater than or equal to. The two negatives on the right cancel out, so we just have 25 over 18. So that is the solution. We need to be able to represent it graphically, so I'm going to do a number line. So put your boundary point on the number line. This is a greater than or equal to, so it's going to be all the numbers to the right. And since it has the or equal to, it's going to be a square bracket or a closed circle. And then we're going to have the smallest value, or the leftmost value, is 25 over 18. And then it goes forever in the right direction, so it approaches infinity, and infinity always gets a parentheses. So that's your interval notation. All right, number 3. We're going to do the same thing here, solve for x. We need to distribute to get rid of the parentheses. So we're going to have negative 6x minus 3 is greater than negative 2x minus 8. Now we're going to move our x's to the left, and we're going to move our constants to the right. Okay, so when we do that, we will get negative 4x is greater than negative 5. We're going to now divide by negative 4. Again, notice we're dividing by a negative. That changes the way these two things relate to one another. So this is now going to become a less than 5/4. All right, so there's the solution. Represent it on a number line, so put 5/4 here. We have less than 5/4, so it's going to go this way. And it's a strict inequality, meaning there's no equal to sign underneath, so parentheses. So it approaches negative infinity, so we're going to have parentheses, negative infinity, comma, 5/4, parentheses. 5/4 is not included in the solution set. All right, so those are some linear inequalities. Number 4 is a 3-part linear inequality. So notice you have 2 inequality symbols, okay? That means this splits it up into 3 parts. So when you're solving for this one, you're still trying to solve for x. But what you're going to do to undo everything around the x, you're going to have to do the 3 parts instead of just 2 sides. So the inequality symbols, you can kind of draw little imaginary lines here. It splits up the 3 parts, okay? So you're going to have to do the same thing to all 3 of these parts. So if you're looking at the middle, we have 5x plus 2. To try to get the x by itself, the first thing we would do is subtract 2. So instead of just 2 sides, you have to do this to all 3 parts. Again, look at these dotted lines that separates the parts. If it helps you to write those, then do that. Okay, so now we have -4 is less than 5x is less than or equal to 10. All right, so we still have these parts. To get rid of the 5, because we want to get the x by itself, we would divide by 5. Again, we need to do that to all 3 parts. We did not divide by a negative, we divided by a +5, so we're not going to flip the inequality symbols. So we will have -4/5 is less than x is less than or equal to 2. All right, we have the x by itself in the middle, so that means we're done solving. Now we need to be able to write our answer in interval notation and represent it graphically. So here we have 2 endpoints, 2 boundaries. X is trapped between them. If you ignore the x and you just look at the numbers, this says that -4/5 is less than 2, which is a true statement. So -4/5 and 2. X is trapped between them. So all you do is color in between those 2 boundaries. And then the -4/5 does not have an equal to sign on that side, so it's parentheses. And then the inequality closest to the 2 does, so that will be a bracket. And you can see the left endpoint, which is the smallest, is -4/5. It gets a parentheses because it's not included in the solution set. And then the greatest value is 2. It is included in the solution set, so it gets a square bracket. All right, so that brings us to the absolute value inequalities. So these are done completely differently. So if you're looking, let's do some kind of basics here. I'm going to erase this so I have some room to do another example above. Okay, so let's say I just had the absolute value of x is less than 2. So first of all, you need to remember that the absolute value is the distance from 0. So that's positive, right? So this is saying the distance from 0 is less than 2. So here's 0. Okay, so this x has to be within 2 units of 0. So that could go this way, right? So it could go all the way over here up until 2, but 2 units away could be to this side as well, right? So everything within this boundary would be within 2 units of 0. So it could go either direction because of the absolute value symbol. So in this case, you can see that the values are trapped between the 2 endpoints of -2 and 2 because it's within a certain range. So you could rewrite this as drop the absolute value symbol and kind of sandwich that in between the 2 endpoints, 2 and -2. So what you would do is you would take this and you just kind of bring it over here, add another less than symbol, and make it negative. That's how you would set it up to solve, okay, when you have a less than. So when you have an absolute value and a less than, you can set it up as a 3-part inequality. Now, let's compare that to when you start with a greater than. So if you have a greater than, so let's say we have the absolute value of x is now greater than 2. That means the distance from 0 has to be more than 2 units away. So let's look at that. 0, 1, 2, 3, -1, -2, -3. So more than 2 units away, greater than 2. So that means it cannot be around 0. It has to be more than 2 units away. So over here, right, anything past 2 would be more than 2 units away from 0. Same on this side. Okay, so if it's greater than, it has to be greater than 2 units away from 0. So that would be these two pieces. So you can see now there are two pieces that would make this work. To set up a greater than and to get these two pieces, what you do is you split this up. Actually, let me write it over here. Okay, so absolute value of x is greater than 2. If you have an absolute value and you have a greater than symbol, what you do is you branch this out into two possibilities. Either x is less than negative 2 or x is greater than 2. So you can see this side, the second side, stays exactly the same. Whoops. This stays exactly the same as this. You just take off the absolute value symbol. And this corresponds to this, right? X is greater than 2. That's what that says on the graph. This side, you have flipped the inequality symbol. So now instead of a greater than, you have a less than, and you switch the sign to negative. But that corresponds to what we have on the graph here, right? X is less than negative 2. So to set up an absolute value, a greater than, you're going to branch off into two inequalities. Okay, so this is an OR problem. So you have to remember the setup. You have to remember to look at the inequality symbol. So number 5, we have a less than. Less than means it's around the 0, right? It's hugging the 0, which means it is a 3-part inequality. So to set this up, we're going to set up a 3-part inequality. So 7 is one endpoint, negative 7 will be the other endpoint. Okay, so we simply take the 7, put it on the other side as a negative, right? That's how we set it up because it's a less than. And now we're just going to solve the 3-part inequality. So remember, if it helps you to draw the lines, to remember to do the 3 parts, that's fine. So we want to get the x by itself. We're going to have to subtract 3 from all 3 pieces. So this is going to give us negative 10 is less than 2x is less than 4. And then the last step here to get the x by itself is divide by 2. We're dividing by a positive, so we don't need to flip the inequality symbols. So we will have negative 5 is less than x is less than 2. All right, so that's the solving part. We did that. Now we want to represent that on a number line. So we have negative 5 and 2. Those are our two boundary points. And x is trapped between them. So we would shade between. They're both strict inequalities, so they get parentheses. And so our interval notation, the least value is negative 5 and the greatest value is 2. Neither endpoint is included in the solution set, so parentheses for each one. Okay, number 6. We need to get the absolute value by itself first before we determine how to proceed. So the first thing we want to do is subtract 4 from both sides. So that is going to give us the absolute value of x minus 2 is greater than or equal to 6. Now, since we have a positive on the right-hand side and we have the absolute value by itself, we can proceed. We see that we have a greater than symbol. The greater than, remember what we do here is we branch off into two equations. So on the right-hand side, the equation is going to stay exactly the same. The inequality, I should say. The inequality will stay exactly the same. You just drop the absolute value. On the left-hand side, remember we want to flip the inequality symbol and change the sign to a negative. So we will have x minus 2 is less than or equal to a negative 6. This is an OR problem. And now we're going to solve these two. So add 2 to both sides. We will get x equals negative 4. And then on this one, we're going to add 2 to both sides. And we're going to get x is, why did I say equals? I'm losing my mind here. X is greater than or equal to 8. The previous problem should have been x is less than or equal to negative 4, not equal to. Okay, so now we have solved both of these parts. So we're going to look at them on the number line. So we have two boundary points. We have a -4 and we have an 8. For the -4, let's see, I will graph this one in green. So x is less than or equal to -4. So it's going this way, and it has an or equal to, so it will be a bracket. And then for the 8, x is greater than 8, so that's going to the right, and it's an or equal to, so it's a bracket. And for the greater than, we expect them to be going in different directions, so this kind of matches our expectations. And now we have two separate intervals that we need to write interval notation for. So the interval on the left is from -infinity to -4. The interval on the right is from 8 to infinity. You just put those together with a U, the union. So when you have two separate intervals, you have to write an interval notation for each one, and then you can kind of combine them with that U, the union. Okay, so now we have 7 and 8. These are the last two for this section. So if we look at 7 and 8, notice we have the absolute value by itself on the left, but notice that we're comparing these to a negative. So number 7 is saying an absolute value is greater than a -6. Remember that an absolute value is positive, right? Because it's a distance. A distance cannot be negative. So this is really asking, so this absolute value is always a positive. So when is a positive greater than a negative? Because this side is negative. So the question is, when is a positive greater than a negative? Well, that is always true, right? Isn't a positive always bigger than a negative? So this is always true. So your answer is going to be -infinity to infinity. So in other words, every number that you plug in for x will work, okay? Because a positive is always bigger than a negative. If we look at number 8, we have an absolute value, so that is a positive, less than or equal to a negative. So this is a less than or equal to. When is a positive less than or equal to a negative? It never is, right? A positive is not smaller than a negative. So in this case, we have no solution. So if an absolute value compared to a negative, if it's a greater than, it's all real numbers, -infinity to infinity. If it's a less than, it's no solution.